We're looking at number 10 here. I have a trinomial, but I have a negative sign in front of the leading term. It'll be a lot easier if I factor out a negative 1. Then I'm left with c squared minus 17cd plus 30d squared. This negative 1 is going to stay down here till the end of the problem and then just tack in after. He's not going to be affected by anything else while we're still factoring. Let's look here. We do not have a coefficient here. We can use the CATS certified method. I notice a lot of you guys are doing grouping. I'm still going to show the CATS method just because it's like grouping, but it's so much easier. Basically, just think of what multiplies to positive 30 and adds to negative 17. Same as if you're doing grouping. It looks like negative 15 and negative 2. So I just rewrite this as c minus 15, or there's going to be a 15d because of the d there, and then I'm going to have c minus 2d there. So a little bit easier than normal. And then this negative 1 just tacks on there. Except this one, as per Ms. Katz, is not as simplified as it can be. We want as few negative signs as possible. Right now we have 1, 2, 3 negatives. If we distribute this into either of these, we're going to get rid of a negative. If we just distribute into here, we're going to have, this is going to become negative c plus 15d, c minus 2d. But then we can switch these and it gets to be 15d minus c, c minus 2d. So this one only has 2 negative signs. That's the fewest we can possibly have. Therefore, we're done with number 10. And this is your final answer. Number 11 on the second page now. We got 12a cubed plus 18b squared. We can factor out a 6. We're left with 2a cubed plus 3b squared. Nothing we can do there. This is a binomial, but there's a plus sign there, so we can't do anything to it. We're done with number 11 here. Number 12. I'm sorry. Looking back at this, it's not number 11. It's labeled as number 14 on the second page. So again, this is number 14 and the answer to number 14. Let's look at number 15. 15 on the second page is a squared minus 36b squared. This is a difference of two perfect squares. A squared, b squared here, and 36 is a perfect square. So we get a plus 6b, a minus 6b. Nothing else we can do here. No GCFs. We are finished for this. Let's look at number 16. These are the ones that you kind of got to worry about just because you got to be good with your fundamentals and make sure that you don't forget anything. We have 6x cubed y squared minus 12x cubed y plus 18x cubed y squared. We're going to factor out a 6x cubed y. There's an x cubed, x cubed, x cubed. That can come out. We have a y squared, a y, and a y squared, so we can only pull out a y. 6 is the GCF. Of these three, I'm going to end up with 1 y left over there, minus 2, and there's nothing else left over here, plus 3y here. We are not done with this because we have like terms inside this parentheses. We have a 1y, or a y or a 1y there, minus 2 plus 3y. I can simplify this to 4y minus 2. I still have this 6x cubed y here. Then I can also factor out another 2 from here. So I have a 2 and a 2y minus 1. This 2 gets multiplied to all this we had outside here. So I multiply that and I get 12x cubed y times 2y minus 1. That's our final answer for number 16. Number 17, we got 3p squared minus 12q squared. This is going to be very difficult to do if we do not GCF out that 3. Now we have p squared minus 4q squared. This is a pretty simple difference of two perfect squares. We have the 3 It's P plus 2Q, P minus 2Q. This is our final answer. There's nothing else we can do. Binomials don't have any perfect squares to them. There's nothing else we can do on that.